Okay, today we're looking at electricity in homes. How does electricity get to your home? So electricity is generated at power plants. Chemical, nuclear, solar, or wind energy is turned into electricity, then transported on high voltage lines, 100,000 volts, to your home. Voltages this high are extremely dangerous. It says that these voltages, electricity can conduct through the air up to 1 meter. So never go near fallen power lines. Okay, when we're thinking about our area, um, there is the BL England power plant that used to be a coal power plant. It's now no longer working right now, but they're looking into wind offshore and then bringing the power lines from the wind, um, to, to the BL England power plant and taking it and delivering it to homes from there. There's also a nuclear power plant in Salem that we also pull from, and a lot of our electricity in New Jersey comes from out of state as well. Okay, but thinking about the power line situation, if you were ever in a situation, God forbid, that you got into an accident and power lines were laying across the ground or across your car or anything like that, never get out of your car. Just stay in your car. For the most part, your car is protected from the electricity. Usually, we'll run around it, but if you get out of the car, now you step and you create a way for the electricity to go from the car to the ground. You could potentially be killed right from that. So you would just stay in your car until uh, until help arrives and they shut off the electricity. Now, if your car is on fire, that's a different story. Then get the heck out. But you okay? So how does electricity safely get into your home from the high voltage lines? We use transformers. Now, transformers can either step up or step down. So you'll see every once in a while, if you're driving or something, you might see what looks like a mini electric, power plant. It looks like almost like a lot of big, huge metal pieces and a lot of wires going to it. That's what they call a substation. And within the substation, there are step-up transformers, meaning that they are taking the voltage and then increasing it more. Because over a certain distance from the power plant, the wires will start to lose voltage. So these will step the voltage back up again so that it can travel further. It's almost like a booster, like it boosts the electricity. But then the things outside of your house that look like either a little box if your power lines are underground, or it will look like a trash can almost that's uh, up in the power pole. They are what they call transformers, and these are step down transformers that are taking the voltage that could be as high as 100,000 volts and dropping it down to what your house would need, 120 volts, um, and it's allowing that to your house to be able to utilize that. If otherwise, you'd have too much voltage going to your house. Every once in a while, those things will blow up, and you'll hear a large bang, and then your power will go out. And it's usually a pretty easy fix for an electric company to come fix that, but usually it's pretty loud when it does explode. Electricity enters your home through the circuit breakers. Each circuit breaker protects one parallel circuit, which can connect many devices. The circuit breaker will trip or break the circuit if the current flowing through it is not correct, prevents fires and electric shock. So a circuit breaker, the way it works is there's a latch. It's a metal latch that's locked. The two pieces are locked together, and then as the current increases, anytime current increases, it will cause metals to heat up. So the wire heats up. The circuit breaker is designed to unlatch as it heats up because the metal will expand, and if it expands enough, the latch releases and no electricity will go through. The idea is that the circuit breaker does this at a lower temperature than your wires will melt. If it was the other way around, then your wires would melt before the circuit breaker tripped, and you'd have the potential for a fire. So if the circuit breaker is working properly, it trips or opens the circuit before that happens, and no electricity can go through. If you go and just switch your switch back chances are it's going to pop again unless you change whatever's causing the increase in current. Okay. I know at my old house, we had too many devices on one parallel circuit. So every time if we had our lights on and something else plugged in, and then we went and ran our microwave, it would pop the circuit breaker. So it was kind of ridiculous. We'd have to go and shut some lights off to be able to microwave our food. So it'd be microwaving in the dark. Okay, home wiring. Like we said before, the home is wired parallel. That way, every outlet is 120 volts. If it was in series, then that voltage would change in every outlet, which we can't have that. We have to have the same voltage. Every device that we plug in our houses in the United States are designed for 120 volts. So we use parallel circuits. And every outlet has 3 wires. We don't always use all 3 wires, but it has the potential for you to plug in something that has 3 prongs. Okay. Current flows through what they call the hot wire into the appliance. This wire delivers 120 volts. And then as it goes across that appliance, the voltage will drop to 0. So it goes back in through the neutral wire. So as the current flows through the appliance and back to the circuit breaker through the neutral wire, which is 0 voltage. The third wire is the ground wire. This connects the outlet to the ground for safety, preventing electric shock. The reason why we don't always use that third prong, some of the things we plug in only have 2 prongs, but if it's a device that is moving, it has moving parts, such as a vacuum cleaner, where it has a motor that's running and moving, or your dryer that's moving and spinning. So anything that has a moving part is going to have a third prong on it. The reason for that is when things move, they rub and they can build up static electricity, and that static electricity has to be delivered or dumped somewhere, and that's usually through the ground. So somewhere along the foundation of your house or under your house, there is a big metal pole that's usually driven into the ground, and that is where your electricity would then dump to. Okay, that's why we call it a ground wire. It literally gets dumped into earth. Other devices do need it as well, like microwaves, different things like that, where there could be buildup of charge. Anywhere where you could have a large buildup of static electricity, you're going to use a grounding wire. Ground fault interrupter. So this is very similar to a circuit breaker. The difference, though, is a circuit breaker looks for increases in current, and a circuit breaker will only pop when it increases to a certain amount. A ground fault interrupter will pop or open the circuit if there's any slight changes in current. So not necessarily an increase, but just a change in general. So any quick change is going to cause that to pop. So it's required in bathrooms, kitchens, and outdoors because those are locations where there is water. So if you're standing and blow drying your hair and you got your water running and you somehow touch it and electricity goes through you, the ground fault interrupter is going to pop because the device is going to detect a change in voltage, a change in current, a quick change in current. So it has a circuit to detect the current flow. If current leaving the hot wire is not the same as the current returning to the neutral wire, the circuit will break. Okay, opens the circuit up. A difference in current could be due to a short circuit or a broken device, or could be that you're touching water. That's why it's in those locations, because it's safety. It's a safety device. Okay. So what is a short circuit? So you'll see, if you remember from the lab the other day, when you had electricity flowing through a device like a light bulb, okay, it was fine and the light bulb worked, okay? But if the electricity finds a path that it can take, that it doesn't have to go through a device that has a higher resistance, it's just going to travel through the wire, and the wire itself does not have enough resistance. So if it has very, very small resistance, then that means the current is going to go really, really, really high. It's so high that a lot of times it would melt the wire itself. Okay, so it's an unintended path that current can travel along with very little resistance. Results in too much current flowing through the circuit and can cause fires. Okay, if someone were to take metal and stick it in your outlet, if you took a paper clip and stuck it in your outlet, which is stupid, don't do that. If it were to travel from one end of the outlet through to the other, you would see a big spark. You could potentially, cause a lot of harm to yourself. But that would be an example of a short circuit because the electricity is going from one end of the outlet to the other end of the outlet with very little resistance and can cause a extreme increase in current and cause a fire. Okay, and that's it.